Who's actually getting the most out of a 12 GPU T-Rack server? If you're running large-scale AI experiments, rendering farms, or a virtual desktop infrastructure that needs a wall of graphics power, this could be the chassis that finally lets you fit it all in a single rack slot. If you're a small business that only needs occasional GPU work, or you're looking for a cheap, just-a GPU solution for a home lab, you might end up overpaying for capacity you'll never use. And for the everyday buyer wondering whether the price tag makes sense compared to a couple of consumer-grade GPUs in a DIY case, the answer isn't as simple as more is better. Link is in the description if you want to check the product details on Amazon. Let's talk about why that decision feels so heavy. The Supermicro SSG 6129P ACR12N4G isn't a plug-and-play graphics box. It's a purpose-built server platform that assumes you already know what you need to do with 12 GPUs. The first thing most people hesitate on is the power and cooling budget. 12 high-end GPUs can pull well over 500 watts at peak, and that heat has to be exhausted from a 2U enclosure that's only 3.5 inches tall. If your data center or office rack doesn't have enough amperage on the PDUs, you'll end up tripping breakers or having to upgrade the entire power distribution. That's a hidden cost that many buyers only discover after the fact. The next hesitation point is networking. This model ships with Supermicro's X11 Deep DM25 motherboard, which gives you dual 10 GB ports. For most AI training workloads, that bandwidth is fine, but if you're planning on moving terabytes of data between nodes every night, you'll quickly run into a bottleneck unless you add a dedicated switch or upgrade to 25 GB. The server's design does give you room for a mezzanine card, but that means another expense and another piece of firmware to manage. Now, why would you actually buy this thing? If you run a research lab that needs to churn through large transformer models, the 12-bay layout lets you pack a lot of compute into a small footprint. Imagine you have a set of RTX 4090s or A100s that you want to keep on site for quick iteration. With this chassis, you can mount all 12 cards side by side, and the motherboard's PCIe 4.0x16 lanes give each GPU a direct, full-speed connection. In practice, that means you can launch a distributed training job and see near linear scaling up to the 12th card provided your software stack is configured for multi-node GPU communication. For a rendering studio, the same setup lets you spin up a render farm in a single rack unit, dramatically reducing the latency that comes with spreading GPUs across multiple boxes. A practical strength that shows up in real-world deployments is the hot swap capability of the drive bays. The 12-bay configuration isn't just for GPUs. The front panel also supports NVMe SSDs, which you can swap without powering down the server. In a lab where you need to switch datasets or snapshot model checkpoints quickly, that convenience translates to minutes saved per experiment. The server also includes redundant power supplies, which means you can keep training even if one PSU fails, an essential feature for any production environment that can't afford downtime. But the strengths come with trade-offs that matter once the box is in your rack. The first practical weakness is the sheer size of the power draw. Even with mid-range GPUs, you're looking at a minimum of 1.5 kilowatts continuous consumption. That forces you to consider cooling at the room level, not just the server. If your rack's airflow is marginal, the server's built-in fans will spin up to high RPMs, increasing noise and potentially shortening the lifespan of the components. The second weakness is the cost of the whole ecosystem. The chassis alone is a premium price, and you still need to buy the GPUs, memory, and potentially a higher capacity network card to get the most out of it. For a buyer who only needs occasional GPU acceleration, a single GPU workstation or a cloud instance might be more economical. Another subtle issue is firmware and BIOS management. Supermicro's platform is designed for enterprise use, which means you'll be dealing with a fairly deep configuration menu, remote management through IPMI, and regular firmware updates. If you're not used to that level of server administration, the learning curve can feel steep. In my conversations with system integrators, they often recommend pairing the server with a dedicated IT staff member or a managed service to keep the firmware in sync, especially when you start swapping GPUs that have their own firmware quirks. So, who should walk away? If you're a solo developer tinkering with small neural nets on a laptop, you'll likely spend more on this server than you'll ever get back in GPU hours. If you're a startup with a tight cash burn, renting GPU time from a cloud provider could keep you flexible and avoid the upfront capital expense. Even for a mid-sized company that only needs a few GPUs for occasional CAD rendering, a 4 GPU or 8 GPU rack might hit the sweet spot better than this.